This is the module information sheet. So you can see there are 5 learning outcomes. So the learning outcomes are the outcomes you should be able to do when you finish the module. So the first one is successfully carry out edit, compile, run cycle. So we will see how to you should be able to do this to compile a program and run it and find errors at the end of the course. And so you must be able to do the variables. So we will discuss them later one by one. So just go through these learning outcomes. Okay, so these are the learning outcomes you will you must know. So these are the ones we assess in the exam as well. So knowing these learning outcomes will be easier for you to follow the exam. And the module outline is there, and the assessment. So continuous assessment is 50% of your marks will be allocated for continuous assessment, and you will be having 2 MCQ exams, and maybe after the mid semester most probably, and then we will be having a final exam. So we will let you know more details about that. And the attendance we cannot check right now because we are conducting online. And the necessary conditions to pass the module is we have 3 conditions. So you have to get 35% of total marks. So it is 50% for continuous assessment. So the raw marks will be 17.5. Raw marks should be you have to get to pass the module. And then for the end exam also you have to get 17.5 to pass, because 35% of 50 is 17.5, and that is not enough. So you have to get total 40% of overall marks. That is from 100 you have to get 40%, that is 40. So you have to fulfill these 3 criteria to pass the module. And then you have to I have given you some recommended reading, and I will be giving more online references for you to follow, and you can follow them. And so you just go through them, and we will discuss these tables later. Okay, so you have the detailed module outcome as well here. So what we are going to do in this. So this assessment schedule will be different because we are having different schedules now. So I will let you know how these things are arranged. So first, in this module we will be learning the computer programming. So in a computer program, what we do is, so we have input and we will have output. Okay, so for what we do is we will be having input and we will be having output. Okay, so for input, there are many ways of doing inputs, like keyboard, mouse, and the microphone. There are so many ways of network, internet, many ways of having inputs, and you can have outputs from your computer, like the screen, and then you can have sounds. Again, you can put your data to the network. Okay, so there are so many output ways of having output. So we have inputs and outputs. So in between, what we can do is we can do some processing. Okay, we have We can have process. So to do the processing, we have to give the computer instructions. So the computer cannot think by itself. So what we have to do is we have to give some instructions for the computer. So this giving instruction, we have to give it one after the other. We call it sequencer. So these instructions are sequences. So that means one after the other. Okay, one after the other. So this is where we write our program. Giving instruction is the actual computer program. So we call this different name. Sometimes we call it algorithm, computer algorithm, computer program. So this instruction is called computer program. The computer can understand only, the computer can understand only electric signals because it's a circuit. Okay, so electric signal only have two states, zeros and ones. The computer instructions will look like something like this. Okay, so these instructions will be similar to something like this. Okay, but the problem with this is, so at the start of the computing, I mean when you develop our first computers, the programmers, so we call these the person who writes these kind of instructions computer programmers. These programmers gave instructions using these kind of ones and zeros. So we use punch cards in early systems. So we have some cards and we have some holes and no holes. Okay, so holes and no holes to represent these ones and zeros. Okay, in early systems in 1960s. Okay, and then so you can see it's very difficult to write instructions using these kind of ones and zeros. So the programmers then develop something called a compiler. Okay, so what we input for this compiler is some program written in a computer language. And the output of this device or this program is the machine code. Machine code is actually ones and zeros. Okay, so the output will be something like this. Okay, so we cannot understand this, but here, so the input for this compiler or this programming code. So the programs, the early programs, one of the earliest in 1969 or somewhere. Okay, they invented C. This was the one of the earliest language. So we use this language to write human readable programs, and we can so now you know, you have seen Python. Python is a language, so you write using Python, print something, and that statement so Python is not using a compiler, it's using an interpreter. Doesn't matter, it's similar. Okay, so this it runs through this compiler or interpreter, and the output will be the machine readable code. We call it machine code, and that one can be implemented using the circuits, electronics. Okay, so it will give the output, process it, and give us the output. So after that, these they develop many programming languages, and the programming languages are becoming easier day by day. So now you have very easy languages like Java, C Sharp, Python. Python is one of the easiest languages, and but so there are some trade-off. That means so the language are easy to write. The programs are more easier to write. But the speed is a little bit slower. So if you write a program in Python, it will be slower than if you write it in the C Sharp, or if you write it in C, it will be the most probably the fastest. So C is most one of the fastest languages we have up to now, and it is very close to hardware. So if you want to write a program which is very close to hardware, something like Arduino or code or something like that, you have to use C for that. So you may have seen some Arduino, these single board computers, processors. If you want to program microprocessors, so you have to you can, most probably you will have to use C-like language. Most probably they are using C. Okay, so C is more close to hardware, and so because of that, you have lots of things which can go wrong. Because you can do almost anything. In the modern languages, they have restricted most of these things. So you are less likely to make these errors. Okay. So now, so we want to give instructions one by one. Okay. So you can see now we will discuss how to do it in C. So now if you want to write a program, so you have to give instructions one after the other. So we will first see how to do it. Okay. So before going into C, I will introduce you to a very basic programming tool, which is we call it called Scratch. And so if you search in the Google called Scratch, so there's a site called scratch.mit.edu, and you can go there, and then you can log in. Okay. And then you can create an account if you want to save your work, and you can create a project. So you can see here there are all the instructions. So these are the instructions you can give to a computer. Okay, so there are instructions to output, like print a statement, say, and make some sounds, and then you have some events, controls, okay, some inputs, okay, and some operations, so on and so on. So there are all these are so this is how we give instruction to the computer. Okay, so to give some instructions to the computer, we need to start somewhere. Okay, it can be so you have to start your program. So here in Scratch, you have this some events. Okay, so this event is when you click this flag, green flag, you have to start your program. Okay, and then so the first thing you can we do is do some output. Okay, so you can drag the computer instruction from these sections, different sections, and uh, align them or arrange them sequentially. So all these computer instructions, you have to align them one after the other. So these instructions will be uh, executed one after the other. So if I run this by clicking, so you have to click this flag, and you can see the output will be displayed, and this cat says hello, and so you can say a sound as well if you want. Okay. So you can make sounds as well. So we will not make sounds here. So this is so you can see you can give instructions like that. Okay. So if you want to give another instruction, say uh, if you want to print uh, the name, okay, so you can get an input now. Okay, so to get an input, okay, so we have to ask a question. So you can use ask in question instruction. Okay, so I ask a question now. Okay, so now so I have two instructions. The first one is say hello, and then I am getting an input asking a question, and ask what is your name and wait. Okay, and so now I want to output this. So I am outputting. So I put another instruction to output. So now I want to output the answer for the question. So I get something like that. So you can see now I have three instructions. First I say hello, and then I ask a question, and then I am going to print the instruction. So now if I type this, it says what's your name. So I print my name, and it print the answer. Okay, so you can see now so when you give instruction line by line, it will execute in that order. This is how you can give instructions to the computer. Okay, so just go through this scratch.mit.edu site. So you go to this site and try writing small programs like this, and understand what kind of instructions are there. So all these instructions are there in almost all the languages. It may be with different format. Okay, so you can see this is a very easy way of learning how the computer works and what kind of instructions are there. Okay, so just go through these commands. So we have lots of commands: motion, looks, sound, event, and